Hello, Algebra 2 students. In this video, I am going to teach you how to use a unit circle to find the 6 trig functions of some things such as 3 pi over 4 radians. But before we go into this, I want to lay down the foundation and explain where the heck all of this information comes from. So if you attended my class, you constructed this unit circle, and it's a lot of information, but I'm going to try to quickly um, break this down. So you'll notice that there's a bunch of these special right triangles on this unit circle. So we have 30, 60, 90 triangles. In a unit circle, the hypotenuse is 1. The radius is 1. That's the definition of a unit circle. So in this 30, 60, 90 triangle, the hypotenuse is 1. In a 30, 60, 90 triangle, the shorter side is half the length of the hypotenuse. So that would be a half. The longer side is the shorter side multiplied by the square root of 3. So we end up with the square root of 3 over 2. In a 45, 45, 90 triangle, if the hypotenuse is 1, we take the side is 1 divided by square root of 2. And then we rationalize the denominator to end up with square root of 2 over 2. On the back of this sheet, we took some additional notes. So I'm going to zoom out even more so you can see why do these triangles matter. If you take any point on this circle, right, you have an x and a y coordinate. The radius is 1 because that's what a unit circle is. And if you can find the sine, cosine, tangent of any angle theta by finding the reference angle and using that triangle. So if I'm looking at this angle here, y is opposite, x is adjacent, and 1 is my hypotenuse. So if I want to find the sine of theta, I'm going to do opposite over hypotenuse, which is y divided by 1, or in other words, just y. If I want to find the cosine of the angle, I'm going to do adjacent over hypotenuse, which is just x over 1. But x divided by 1 is simply x. Tangent is opposite over adjacent, so y over x. Then we have our reciprocal functions. If sine of the angle is y over 1, then the cosecant's 1 over y, but we have to be careful. You cannot divide by 0, so that value cannot be 0. Make sure your denominator doesn't end up being 0. I will make a separate video with some examples of where you might see that. If the cosine of the angle is x over 1, then the secant's 1 over x, right? We just take the reciprocal of this. And if tangent's y over x, if I take the reciprocal, the cotangent's x over y. Okay, now, why does this matter in our unit circle? So let me go back to that. Okay, 30 degrees is a 30, 60, 90 triangle. Where the heck does this ordered pair come from? Well, that's because we go right a distance of root 3 over 2 and up a distance of 1/2. So that's where that ordered pair comes from. This ordered pair is a 45, 45, 90. So we go right a distance of root 2 over 2 and then up a distance of root 2 over 2. So to plot this point, we have to go right root 2 over 2, up root 2 over 2, which is this. For 60 degrees, we go right a distance of 1/2 and up a distance of root 3 over 2, which is where that comes from. Well, we just realized here that cosine is just the x value and sine is just the y value, which is why I have that written up here. So let's use that information to start the first problem of this worksheet. So for the first problem, we are going to use our unit circle. Okay, 3 pi over 4 radians is here. It's 135 degrees. Well, we just realized that in the unit circle, the cosine of the angle is the x value, and the sign of the angle is the y value. By the way, an easy way to remember that is alphabetical order. X comes before Y. C comes before S in the alphabet. So that's one way that could help you remember that. Okay, so if I want to find the sign is just the Y value. So that's root 2 over 2. Cosine is the X value, negative root 2 over 2. Tangent is Y divided by X. So I'm going to take the Y value and divide it by the X value. So my Y value is root 2 over 2. My X value is negative root 2 over 2. Now just think about what's happening there. If I have root 2 over 2 divided by negative root 2 over 2, you have something divided by itself. That would be like doing 5 divided by negative 5, which is just negative 1. So the tangent is negative 1. Okay, to find the cosecant, I am going to remind you that root 2 over 2 was technically 1 over root 2, but then we rationalized it. If I go to here, when we were finding the side lengths, x is root 1 over root 2. But then we rationalized it to get this. It's easier to take the reciprocal of this. The reciprocal of 1 over root 2 is just root 2 over 1. But root 2 divided by 1 is simply the square root of 2. Now, if you don't remember that, if you don't remember, oh, root 2 over 2 is just 1 over root 2, you can take the reciprocal of this. It's going to take a little bit more work, but that's okay. So if I take the reciprocal, that's 2 over the square root of 2. But we need to rationalize the denominator, and you end up with 2 root 2 divided by 2. 2 divided by 2 is 1, so you're left with square root of 2, which is what we got as our answer. Secant, you'll notice we have the same thing, just with a negative in front. So the reciprocal is going to be negative square root of 2. Cotangent, if tangent's y over x, then cotangent's x over y. And same thing here, you're going to get negative 1. Remember that a number divided by itself is 1. So this is like doing negative 5 divided by 5 would give you negative 1. It's that same concept. So that was with like looking at our unit circle. But here's the thing. You don't get to use your unit circle on the quiz or test. I know, take that in for a moment. So how the heck am I going to do this without my unit circle? Well, I am going to teach you that if you know how to sketch an angle, know where an angle lands, and you know the special right triangle that goes there, that's all the information you need. And you don't need to memorize all of this. So I'm not saying to never use your unit circle. When you're first learning this, absolutely reference it if you need to, 100%. But our goal as we keep practicing is to not have to look at this. So let me show you how to do that. I'm going to pick an angle or a radian that we don't see on our unit circle because that's going to happen. Sometimes you have degrees that are more than 360. So that means you can't just find the answer right away. You still have to have that skill of knowing which special right triangle to use. For example, 300 degrees, that is on your unit circle. So you can try this problem just like I did this one, just like I did part A. But let's move on to one that's not on our unit circle. I'm going to use this as an example. Moving forward, I'm going to do E and F, and I'm not going to look at the unit circle at all. I'm going to use the skills we've already learned. And by the way, this doesn't mean, well, then why did we learn the unit circle? It's still important. You need to know where all of the values on the unit circle come from. But this is a good thing, though, is maybe you should feel relaxed that, oh, I don't have to memorize a whole unit circle. Okay, so how do I do that? 13 pi over 3. It's like, oh no, fractions. Okay, well, let me equip you with the number sense and the skills to get through this. This is, if I think about what's going on here, okay, well, I can't do 13 divided by 3. I would end up with a decimal, or I know it's not a whole number, but I do know that this is 12 pi divided by 3 plus 1 more. There's an imaginary 1 here. So I can think about this. Wait, but this is just 12 pi thirds plus 1 more pi third radian. 12 divided by 3 is 4. So what's happening here is I have 4 pi radians plus another pi over 3. Again, I'm not going to look at the unit circle. I am going to visualize what special right triangle I need to use to figure this out. We know by now that 180 degrees is pi radians. A full 360, so if I double that, is 2 pi radians. So what is 4 pi? Well, that's just twice around. That would be 2 pi. So 4 pi would be double that. So that's 4 pi radians. 2 pi, 4 pi. Now I have an additional pi over 3 radians. So that is here. Now, how did I know that? Well, I do know that this pi over 3 means a third of the way to pi. Or if you know pi is 180, 180 divided by 3 is 60 degrees. This is equivalent to 60 degrees. So I end up with a 30, 60, 90 triangle. So I'm going to sketch that triangle. Now again, notice I'm not looking at my unit circle because this radian isn't even on the unit circle. So you have to have the skills to know that it's twice around plus 60 more degrees. So I was walking you through that process. Well, this is a 30, 60, 90 triangle. I know that if my hypotenuse is 1, this is 1/2, and this side length is root 3 over 2. Okay, well, if I want the sign, opposite over hypotenuse, root 3 over 2 divided by 1 is just root 3 over 2. It's just the y, right? If that was a point, it's just the y value. Cosine's the x value. Cosine is adjacent over hypotenuse. A half divided by 1 is just a half. Now this is where things, we gotta end up dividing fractions next. Tangent is opposite over adjacent. So we're gonna do root 3 over 2 divided by 1/2. Now, how the heck do I do that? I just want to remind you that when you divide fractions, we multiply by the reciprocal to get the same thing. So dividing by a half is the same as multiplying by 2 over 1. So we're going to take the reciprocal of the second fraction. And notice that the 2 divided by 2 is 1.